In this video, let us look at the Hugging Face H4 Labs latest Zephyr ORPO 141 billion parameter model. We will try it out on Hugging Face chat. We'll also look into a little bit detail on how this model was created. So this is the latest Zephyr model in the series of Zephyr models from Hugging Face H4 Labs. These language models are trained to act as helpful assistants. Now, the Zephyr 141 billion A35B model is actually a fine-tuned version of the Mixtral 8 into 22 billion model, which was released few days ago. And this model was trained using a novel alignment algorithm called odds ratio preference optimization with 7K instances for 1.3 hours on 4 nodes of 8 into H100S. Now your Mixtral 8 into 22 billion was actually a very powerful LLM. Its performance was between say Claude Sonnet and GPT-4. Now that model has been further fine-tuned. Okay, that's how they got this Zephyr 141 billion A35 billion parameter model. Now, what is this 141B and A35B? So 141B is 141 billion total parameters. So this is a mixture of experts model, as the Mixtral 8 into 22 billion was an mixture of experts model. This was a fundamental model. Okay, this is a fine-tuned model, Zephyr. Okay, and there are 35 billion active parameters. This has been trained on this particular data set, argilla, distill, label, capybara, DPO 7K binarized preference data set. It's a mixture of synthetic high quality multi-turn preferences that have been scored via LLMs. Okay. Now this model is available for commercial use. Let me check the license. It is Apache 2.0. Okay, they have put the performance over here, and this model is already available on the Hugging Face chat. So I wanted to try out few use cases over here to just see how it performs. So let's quickly look into it. So the first one was I wanted to try a simple mathematical calculation where I said that I bought 5 pencils for 35 each, 5 drawing books for 67 each, and paid ₹1,000 to the shopkeeper. How much change should the shopkeeper return to me? A simple mathematical calculation. It has to calculate the total amount for pencils, total amount for drawing books, and subtract that from total it and subtract it from 1,000. So that is what it exactly does over here. It calculates the total cost of pencils, the total cost of drawing books, sums it up, subtracts it from the total amount, and it says 490 rupees as change. So it has given a right answer over here. Then I tried a slightly tricky question, which I said, I was 10 years old when my brother was half my age. I am 50 years old now. What is my brother's age? So I am 50. When I was 10, my brother was 5 because he was half my age. Now I am 50, so my brother should be 45. It gets it wrong the first time. Okay, it does this twice calculation and it gets it wrong. Then I said think logically for the above. It comes up with the proper explanation and it also gives the proper answer over here. Okay, this question has been a little bit tricky for LLMs because it needs to infer the meaning properly over here. But yeah, it is after prompting it saying think logically, it has given the correct answer over here. Okay, that is if I am 50 years old now, my brother is 45 because when I was 10, my brother was 5. Okay, simple. We have a 5 years age difference. That's what was this problem about. Okay, now I wanted to try a named entity recognition problem. Okay, because I frequently work on named entity recognition problems with LLMs. So I said, can you extract entities like person, organization from the below text and create a JSON output file with entities? So this is the text. Here, if you look at, there is Mark Zuckerberg as a person, there is Meta Platforms as an organization, there are these people, Andrew McCallum, Eduardo Saverin, and so on. It actually pulls it and puts a proper JSON over here with entities, person Mark Elliott Zuckerberg, organization Meta Platforms, organization Harvard University, and so on. Okay, organization Chan Zuckerberg Initiative. Now I said, can you extract the entity spans and populate the JSON? It gives the entity span as well. Now to verify it, I said that, okay, why don't you create an HTML file and highlight these entities? Okay, that's what I said over here, and it gave me an HTML, with the highlights. and I copied this HTML content and checked it out, and see, this is a thing, output text, right, of the HTML. When the HTML is rendered, it has actually highlighted all these entities. Okay, probably I could have said that, okay, highlight different entities by different colors, it would have generated the code. Okay, this was named entity recognition. Then I said, okay, there was this example over here which they said that you can try out HTML code for a snake game. Okay, one thing which I forgot to mention is that when you are creating a new chat with Hugging Face, select this particular model, Hugging Face H4 Zephyr ORPO 141 billion. Only then this model will be running it. Okay, they also offer a lot of choices for various other models. They have Mistral 7B Instruct, they have now Hermes Tubium. This is the Mixtral mixture of experts 8 into 7B. Okay, they also have Cohere for AI Command R plus. I wanted to try out this H4 model. Okay, this particular Zephyr model. Now, if you go over here, I wanted to try to create a HTML code for snake game. Code a snake game in HTML, because they had this example of code a snake game in Python, and give explanations for each step. It did a very good job over here. It said first import the libraries like pygame, random, then do this init, and then set your display, then define some colors, then create a snake class to represent the snake, create a food class for the food, and then the movement directions of the snake, and so on. Okay, but when I tried it on HTML, after repeated attempts also, I couldn't get a proper working code. All I got was this particular code, right? For this, none of the keystrokes or anything works over here. Probably an HTML expert can debug this code. But yeah, then I wanted to try another use case where I wanted to try something like giving a medical report and asking it to extract disease diagnosis. So this was an echocardio report, an echo Doppler report, and then I asked it to extract disease diagnosis, right? So if you look at this report, there are some things like left atrium is moderately dilated, mitral valve is this thing. So here is a conclusion, right? Left atrium is moderately dilated, elongated, there is severe symmetric left ventricular hypertrophy. It actually pulls all those stuff over here. Okay, it pulls all those disease diagnosis, right? And then I said, can you convert to ICD-10 codes? With the web search enabled, it failed. Then I said without web search, it gave me certain codes over here, but when I try, say for pericardial effusion, if I try this I31.2, ICD-10 code, it doesn't give actually proper proper diagnosis. Actually, I31.3 is for pericardial effusion. This is for hemopericardium. So some mistakes like that happen over here. So it is not, I would say that probably it has not been trained on such data where to pull ICD-10 codes. This is a specialized problem. So maybe this model needs to be fine-tuned on medical data where you have corresponding ICD-10 codes along with the conditions, and probably then it can recognize it. But these were some small use cases which I tried, and it kind of, worked, right? So probably I can try another chat where I can ask it to, write a poem. Write a poem on LLMs. Let's see what it does. This is just looking at the creative text generation. Okay. Wow. In the realm of code and thought, when algorithms are taught, a new intelligence has been wrought. Oh, it is maintaining the rhyming. Nice mix of words. They call it LLMs, a marvel of technology that can learn and understand with neural networks so fast and processing power that's unmatched. Okay, it's written a nice poem, I would say. Okay, right? So these were some use cases which I quickly tried out. What I am interested is learning more about this ORPO optimization technique, which stands for odds ratio preference optimization. There is this paper which talks about monolithic preference optimization without reference model. Probably I would want to get into the details of this particular technique. At a high level, it is about creating your chosen responses and rejected responses, and then trying to optimize the model by having this odds ratio calculation, whereby what it tries to do is that it tries to assign a weak penalty to the rejected responses and a strong adaptation signal to the chosen responses, with a simple logs odds ratio appended to the negative log likelihood loss. So when you are training a model, fine-tuning a model, you have your loss function from supervised training, okay, supervised fine-tuning. Along with that loss function, they add a relative ratio loss, okay, and the relative ratio loss is about the preferences. It is a ratio between your preferred responses versus your rejected responses. That's what it is about at a very high level. Probably I'll go into the details of this paper. For the moment, I will just put a link to this paper and you can look into it. I hope this video is useful to you. So this is one of the first fine-tuned versions of the Mistral 8 into 22 billion mixture of experts model. It was a base model and this is a fine-tuned model. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. I'll be putting all the relevant links in the description of the video. Do check out. See you in another video.